Welcome back. I believe this is our last section. So what makes the Earth so unique? Well, let's talk about it, shall we? We really need to appreciate the Earth for what it is, what it provides for us, everything. And my hope here is that, as we go through this class, you'll, by understanding Earth a little bit better, maybe take a little bit better care of it. But in any case, what makes us so unique? What makes us different than some of our neighbors? Well, we have an atmosphere, which is not unique. Other planets have atmospheres. I think all of them but Mercury. But what is unique is that our atmosphere is rich in oxygen. Oxygen, in fact, is not the most abundant gas in the atmosphere. That's nitrogen. But the fact that we do have enough oxygen to sustain life, that makes us unique. We have a hydrosphere. Again, also not unique. Other planets have water, but they don't have it in the three different varieties that we do. We have water as solid, liquid, and vapor, gaseous in the atmosphere. So that is kind of unique. Because of those two, that might be the reason we are the only planet that we know of that has a biosphere full of living organisms. Possible fossil evidence of things like bacteria have been found on Mars, but nothing large scale that we know of. Also, we have weathering, which is the breaking down of rocks, as well as chemical alteration of rocks. So rocks are broken down and they're changed on the surface. A lot of this is driven by the hydrosphere and the water cycle. We have a regolith, which is the blanket of loose debris covering the earth, i.e. soil. One component of soil is organic matter. Any of you that have done any gardening or anything like that knows that soil is not just dirt, it's dirt and organic matter. Leaves and grass and dead things, fertilizer, poop, that kind of stuff. So since we're the only planet that has living organisms, we're the only one that really has fertile, rich soil. And it's constantly changing as well. Other planets do. We can understand, and we've seen plate tectonics going on other planets, as well as other satellites of planets within our solar system. More on that next unit. So Earth is a dynamic system. There's all these things interacting, and it's constantly changing. But it's uniform in its processes. Uniform meaning, consistent, the same in the types of processes that have occurred. And this is the basis of uniformitarianism. Say it with me now. Uniformitarianism. Fun word. I mentioned this, I believe, back in section 2 when we were talking about the history of geology and some of those famous people that really helped geology as a science, one of those being James Hutton. So he proposed this idea of uniformitarianism. Now, when I discussed it, it was kind of a common sense deal. But uniformitarianism, it states that the processes governing the Earth's systems today have operated in a similar manner throughout geologic time. So we have volcanoes today. There must be volcanoes in the past. Whatever is driving that must have continually occurred. We have earthquakes now, therefore we've had earthquakes in the past. Whatever process is driving that, whatever systems are interacting, have been doing so this whole time. So it's kind of a common sense deal, but again, someone has to say it for others to agree with it. You can kind of boil down uniformitarianism to the quote, "The present is the key to the past." We can't travel millions of years ago, billions of years ago to see things forming, rocks forming, mountains forming, whatever it may be, the Earth forming, the solar system forming, the universe forming. We're not Marty McFly. We don't have a DeLorean, nor do we have a Doc Brown, nor do we have gigawatts, which is not even gigas, just gigawatts. Anyway, I digress. So, the present is the key to the past. Therefore, if we want to understand Earth's history, we just got to be present, and we got to look at what's happening now, the processes, as well as the Earth, the rocks that we have. We can pick up a rock and say, "Oh, okay, this is this type of rock, but to be here, it must have had formed millions of years ago." So it's kind of giving you an indication of what the area was like, or how that area formed millions of years ago. For example, there's a lot of places you can walk around in Arizona and pick up volcanic rocks. The reason being, millions of years ago, there was a lot of volcanoes in Arizona. And we can find the remnants of that. We can find the rocks that tell us that. What is this doing here? Oh, must have been a volcano here. So the present is the key to the past, simply put. So again, volcanoes happen now. They must have happened in the past. Earthquakes, landslides, shifting earth happen now. Must have happened in the past. Same processes must have been occurring. Weathering and erosion, the breaking down of rock and transportation of that material, weathering and erosion occurs now, must have occurred in the past. So, again, Earth is a very unique and dynamic place. The plates that make up the outer crust, which is broken up into large plates, are constantly and slowly moving over time. While previously unknown to us, I'm going to think back to Aristotle, back in the 4th century BCE, saying, the Earth is changing, but it's very, very slowly, and we can't even see it. Well, he was right. How do we know he was right? Well, we can use modern day technology to figure it out. We can use GPS to track the movement of these large slabs of rock that make up the crust that's broken up into these large pieces called plates. We can track them, how fast they're moving with GPS, so we can see that and observe the motion and the direction and the speed, etc. How we figured it out prior to that, not but even less than 100 years ago, we'll get into next unit. But according to the principle of uniformitarianism, say it with me now, uniformitarianism, this process which is driving the plates now must have also occurred in the past. So the processes haven't changed. We will dive into plate tectonics. That's all of next unit, and that will lead into things like earthquakes and volcanoes. But just to briefly give you a preview, plate tectonics is the movement and interaction of large plates of Earth's crust. It's really responsible for shaping the continents, literally what they look like, the things that are there, as well as geologic entities like volcanoes and earthquakes and how they occur, all due to plate tectonics. When these large slabs of plate are kind of interacting, there's two types of crust that make up the crust. There's two types of crust that make up plates. Sometimes plates are only made up of oceanic crust, which is kind of young, thin, and more dense, heavier crust material, or sometimes they're continental crust, which are typically older rocks, thicker slabs. They're thicker plates. They're less dense, so they're a little bit lighter. Sometimes tectonic plates are made up a little bit of both, but it's the interaction of these two things that is driven by what's going on inside the Earth that creates geology as we know it. So when we're looking at kind of this slab over here, this is the continental crust. Again, it's thicker, it is less dense, believe it or not, a little bit lighter. So it floats a little bit higher. This is the oceanic crust, this black material. It's usually thinner. You can see it's kind of thinner, but it is more dense, made up of kind of a little bit heavier material. More on this in later units. Again, it's just a quick preview. And it's the interaction and movement of plates. So we have this oceanic plate crashing into this continental plate. So they're crashing in together. The oceanic plate getting driven down into the mantle, which we have down here, that mostly solid hot Play-Doh with kind of rocks mixed into it, but it's what's going on down here in the mantle, which is driving plate tectonics up here, and the collision of these plates creating these mountain ranges, volcanoes, possibly some earthquakes. It's a gorgeous dance that the Earth does, a very gorgeous dance that the Earth does. And that, again, just a little preview, and we'll touch on all of that in Unit 2. But for now, let's wrap this up. So as we approach the end of each unit lecture, I talk about the big ideas. The big ideas are just kind of going back through, thinking back what I've talked about, what I've showed you, what you've heard about, and what really is important. When I assess you on test, I really only focus on the big ideas. Not every detail I think is worth being assessed. I never appreciated, nor did I enjoy, those types of tests in college that were just, the questions were the most littlest detail, only to check to see if I've really paid attention and read every little word that in the textbook or whatever. I hated that. That does me no good. So when I assess you on kind of the bigger ideas. So at the end of each lecture, I give you the kind of the big ideas, something to reflect back on what you watched and heard, and that's really what I want you to kind of remember and focus on. So as I give you these big ideas, kind of think back to how what I talked about pertains to these, and again, it'll be these types of big ideas that I will assess you on come tests. So what are some of the big or main ideas as it pertains to geology and Earth's formation? Well, think back to what is geology and why should we study it? All right, geology, the study of Earth over the past 4.56 billion years, and why should we study this thing called geology? And that was discussed in, let me get rid of this here. And that was discussed back in section 1. That's what you'll see here. The solar system formation, the nebula theory, accretion, how the solar system formed, how the Earth formed, etc. So that was back in section 3, kind of the steps to that. As you can see, section 2, the history of geology, not a bigger idea. That's when I discussed the names in geology. That's interesting to know, but at the end of the day, it's not the most important thing. Differentiation and the layers of the Earth. Back in section 4, we have the crust, mantle, outer core, and inner core, and their consistencies. Are they solid, liquid, mostly solid? What's going on there? And then that idea of uniformitarianism, present is the key to the past. You can kind of see section 5. These are Roman numerals, by the way. This is section 6. Section 5, I think we were talking about Earth systems. Yeah, that may be good information, but not the biggest of ideas, main ideas, not really something I would assess you on. So the big ideas at the end of the unit, there might be 3, 4, as you see here, sometimes 5 or 6 kind of main big ideas. But again, whatever these are kind of the focus. Think back on these, reflect on these. If you're the type that needs to review and take notes, go back and take some notes on this if you want to, but definitely not necessary. Again, this is what I will assess on, but you can use material, all the class material on test. So you can use the PowerPoints and you can have those with you as you work on the test. So that brings us to the end of the Unit 1 lecture. I don't typically do this, but again, the super secret password is 1111. So 4 ones in a row. That's the code you will input for the assignment that you can do now that you're done with the lectures. That's the code you'll need to access the assignment in Canvas and get that submitted. Again, I typically don't give that again after I've already given it, but it's Unit 1 lecture. It's the first time, so I just want you to get used to that. Again, that super secret code is 1111, so 4 ones in a row, 1111. Just a reminder, please get on top of your assignment. This class moves quickly, so don't delay, don't dilly-dally. So get that assignment done. It's been my honor, it's been my pleasure, and I will see you next time for Unit 2. Bye-bye.